Hello friends, today we are going to be fixing my Keurig K Supreme Plus coffee maker that no longer turns on. The coffee maker stopped working after the water reservoir was removed while the machine was running. This caused the pump to run dry and the heating element to overheat, which tripped the thermostatic fuse which cuts power to the machine permanently. We are going to manually be resetting that fuse. We are going to begin our disassembly by removing this top piece of plastic which is held on with snap fit clips. I broke one of these clips, but it shouldn't matter. Circled in red are the snap fit clips that hold this top piece of plastic down. The other things you see are locating pins that prevent the sides of the machine from being pulled away while this is attached. Here's a top-down view of what the machine looks like with that top piece of plastic removed. Along the perimeter you can see holes where those locator pin things would enter to prevent the sides from being pulled away. We're now going to remove these 3 Phillips screws from the bottom of the machine. 2 of them are hidden behind these plastic feet that prevent the machine from sliding around. All 3 screws appear to be identical. We're now going to pull this piece of black plastic up and out. Here you can see all the hooks that were holding it in place and the flat plastic tab at the very bottom. It's only the top piece of plastic that prevents this from being removed. Here's a quick overview of what the machine looks like with this removed. Unfortunately, we can't yet reach the thermostatic fuse reset button. We're now going to pull the housing off the machine. There's a single giant piece held on with snap fit clips. I recommend working it from this bottom left corner where you see my right hand is holding, and then working your way across the side and then up, and then loosening the other side, and the entire thing pulls forward and away from the machine. Here's a quick look at the housing we just removed. You can see most of the clips are focused around the front of the machine and the top. Here's where that black piece of plastic we just removed would go. You can see all the hooks that would engage it, both sides here. You can also see that at the very front there's two locating tabs and two clips that require that the housing be pushed forward into the machine. You can see these clips hold on the side. There's two vertical rows of clips along the front here. And on the bottom you see there are no clips. Instead there are holes for the 3 screws, 1, 2, 3 that we removed earlier. You also see these metal tabs along the perimeter. These are used to hold the outer skin or cladding of the machine. You can see here that seams in the cladding line up with the metal tabs on the inside. You can also see that the power cord is a notch instead of a hole because the cord is already installed before this is. We can now see the water heating element, which is that black tube in the middle, and the thermal fuse, which is that white circle with the 2 wires going to it, and that small black dot in the middle is the reset button, which you're going to put a pin through to reset it. Here's what the heating element looks like when removed from the unit. You can see the thermal fuse is attached directly to the heating element. Water enters from the bottom of this heating element, then loops around the resistive heating element until it's expelled out the top. It's done like this because hot water naturally rises. The thermal fuse is located at the top of the heating element as heat naturally rises. Additionally, the 2 wires going to the thermal fuse provide power to the entire machine. So when the fuse trips, not only does the heating element lose power, but the entire machine loses power. When the water reservoir was removed from the machine, this heating element immediately ran dry, and since water was no longer cooling the heating elements, the temperature rose rapidly, tripping the thermal fuse. Set the multimeter to continuity test mode when the probes touch or there's a conductive path between the probes. The meter makes this beeping sound. Touching the 2 wires going to the thermal fuse with our multimeter probes, we hear no beeping sound as there is no continuity. We're now going to push this paper clip into the hole in the middle of the thermal fuse to reset it, and then once again test continuity. As indicated by the beeping sound, the fuse has been successfully reset, and we now have a continuous path for electricity to flow through the fuse. All that's left to do is to follow these steps in reverse to reassemble the machine. The only difficulty I had with reassembly was getting that top plastic clip back in place, as it required the housing be slid front to back. This is effectively the end of the video, but feel free to stick around for a couple more minutes if you'd like to hear me talk about how the machine works. The Keurig is equipped with this gravity-fed internal water reservoir. On this side, you can see a thermal probe which goes straight to the PCB, and on the other side, you'll see these 2 red and green wires. These are probes that are used to measure the water level. If there's continuity between these probes, then you know the water level must be above the higher probe. So therefore, if the water level of the external tank goes low, like kind of to where my hand is, and is below that higher probe, continuity is lost between the red and green wires, and the machine tells you that the water level is low. Here's a photo of what this internal reservoir looks like when removed. On the right, you'll see the thermal probe, and on the left, those 2 probes are used to detect water level. As I said before, when continuity is detected across the 2, then it knows that the water level must be above the higher probe. The 2 hoses on the bottom of this both go to the external tank. 2 hoses are needed because the external tank is not ventilated, so one of them must allow air into the external tank. And the 2 hoses on the top, one goes to the pump and one goes to a vent, or acts as a vent. Here you can see that vent tube. It goes straight through this plastic wall here, and it vents straight into the body of the machine. You'll notice that there's this plastic wall that divides the electronics from where the vent outputs. This is to prevent the electronics from getting wet. The other hose from that internal reservoir feeds into this water pump right here. The output direction of the water pump is indicated with the blue arrow here, and it goes along this path to the bottom of the heating elements. I've also noticed there's this air compressor that's teed into this output of the water pump. This air compressor serves two main purposes. One, it can be used to temporarily increase the water pressure to allow the coffee grinds to saturate more effectively. And two, it can be used to dry both the heating elements and the K-cup, and to cool the K-cup to make it easier for the end user to handle immediately after the coffee has been made. This air compressor functioning correctly would prevent what this person is describing, where the K-cup is retaining a lot of water after the coffee has been brewed. After the water is heated, it enters into the bottom of this plastic manifold. The first hose on the bottom right, the very short one, is essentially a ball and a spring, and it's an overpressure relief valve. It opens up when the pressure is too high and vents into the same area that the internal reservoir would vent to. It's the reason you'll sometimes see a puff of steam when you open up the machine to replace the K-cup. The very narrow hose on the top right goes to the pressure sensor on the printed circuit board. It's how the computer is able to determine the output water pressure. If the output water pressure is too high, the computer knows that the overpressure relief vent is likely open and will shut down the machine to prevent too much steam from being produced and expelled through the overpressure relief vent. The large hose on the left goes into the nozzle that feeds the K-cup. Here's what that assembly looks like when removed. You can also see the thermal probe in the bottom left. We have now traced the path of water from the external reservoir to the K-cup into the end user's belly. Thank you so much for watching. Please leave any comments, questions, or concerns down below.